NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1 has broken free from the sun's protective bubble, stepping into the vast unknown of interstellar space.
How did these incredible machines manage to accomplish so much beyond the scope of their original mission?
But what it detected out there left NASA stunned.
But they continue to send us incredible new information about our universe from interstellar space.
Mysterious signals, unexplained changes. What's really lurking in the space between the stars? Could these findings reshape our understanding of the universe? This is the tale of Voyager 1, the most distant man-made object in history. And what it finds at the furthest reaches of our solar system will make you re-evaluate all you believe to be true about space. This is not your typical space mission, so fasten your seatbelt. Over 4 decades have passed since Voyager's journey began, and the astounding discoveries it has returned are beyond anyone's wildest expectations. Let's get started. The probe that keeps going and going. Launched in 1977 to investigate Jupiter and Saturn, Voyager 1 is more than just a spacecraft. It is humanity's most extensive mission. Its original purpose was to fly past these planets, collect information, and transmit it back to Earth. However, what began as a temporary mission evolved into something far more remarkable. Voyager continued on its course after finishing its grand voyage, exploring far beyond the solar system and into the unknown. During its voyage, Voyager crossed the barrier into interstellar space, which is the area outside of the solar system where the power of the sun diminishes and the forces of the galaxy assume control. 2012 saw the historic crossing of the heliopause, the boundary between the solar wind and the interstellar medium. The first man-made object to reach this unexplored region was Voyager 1. It started to see previously unseen phenomena as it moved into the emptiness. Cosmic rays colliding with interstellar plasma produced plasma waves, which are ripples in space, which were one of the initial surprises. Scientists had not anticipated these waves at all. Additionally, Voyager began to detect unusual pressure at the solar system's outer edge, which caused scientists to reevaluate their understanding of this boundary. The cause of this pressure is still unknown, but some people theorize that it might be caused by cosmic rays or magnetic fields. The fact that Voyager started to detect a constant hum in the interstellar medium was even more intriguing. This hum, formerly believed to be background noise, was actually a low-frequency vibration brought on by plasma waves. By exposing the galactic environment located far outside of the solar system, this continuous signal contributes to a better knowledge of the nature of space. Voyager is also assisting scientists in mapping the density and composition of the interstellar medium, a crucial component of the galaxy that affects galactic evolution, star formation, and potentially even the conditions for extraterrestrial life. By measuring these plasma waves, Voyager is transforming our knowledge of the interstellar medium with every new piece of data. The findings don't end there either. Unprecedented new information about the interstellar medium's response to cosmic rays, fluctuations, and behavior when the sun's influence starts to diminish is being made possible by Voyager's equipment. Scientists' preconceived notions about space outside of our solar system are being challenged by this data. What implications does all of this have for earthly life? These discoveries may contribute to our understanding of the formation of planets and stars, the evolution of galaxies, and the possibility of life elsewhere in the galaxy. The information that Voyager is returning could put us one step closer to finding the elusive answer to the issue of whether we are alone in the universe. Despite the difficulties posed by distance and declining power, Voyager is nevertheless returning useful data to Earth. NASA is forced to turn off non-essential systems in order to save energy as its power, which is produced by a decaying plutonium core, diminishes annually. Voyager's mission isn't finished yet. We go closer to answering not only the questions we have posed, but also the riddles we never even considered tackling with each new discovery. The voyage of Voyager 1 is proof of the strength of human curiosity and the extent to which we will go in order to learn more. One discovery at a time, its data is pushing the limits of science and technology. as it travels into the vastness of interstellar space, assisting us in discovering the universe's mysteries. The edge of the solar system, a strange new world. Voyager 1 began discovering increasingly odd occurrences that no one had predicted as it ventured farther into the unknown. Voyager experienced unanticipated rippling in the fabric of space itself beyond the heliopause, the point at which the pressure of the solar wind eventually diminishes into the emptiness of interstellar space. This wasn't just ordinary cosmic activity either. It was something completely different from anything we had before seen. In the furthest regions of the solar system, scientists believed they had a fairly solid sense of what to expect. Then, however, Voyager started to detect strange plasma waves. These were complicated, echoing waves rather than merely basic energy bursts, as though the universe itself were vibrating with an odd form of energy. When scientists transformed those waves into audible sound, it was as if they were listening to the hum of the universe itself. They nearly resembled an intergalactic heartbeat, sending pulses of sound across the vacuum of space. Imagine the sound of that now. A low, uncanny hum that would resemble the resonance of a massive cosmic instrument that had been playing subtly for billions of years. It's a beat, a throbbing sound that reverberates throughout the boundless void of space, not simply some static noise. What more might be out there, you ask yourself? What causes these waves, and how does this affect our knowledge of the universe? There are more questions than answers with the discovery of these enigmatic plasma waves. What effects do these interstellar waves have on our solar system's magnetic fields? Could the continuous pressure we're feeling be the result of deeper invisible forces in interstellar space, or is it an indication that something is pushing on our solar system? The first hint that something far more enigmatic and potent, something we've only just begun to glimpse, exists outside the borders of our solar system, might be this hum, this odd and seemingly alien sound. The mysterious hum of interstellar space. More than just an unsettling noise, the hum Voyager heard in the immense void of interstellar space contains a wealth of knowledge about the basic makeup of the cosmos. This hum serves as a cosmic fingerprint for astronomers, providing crucial hints about the environment outside of our solar system. Theorizing about the density of interstellar space is one thing, but actually hearing these plasma waves is quite another. This data is raw, real-time information about a place we have only just begun to investigate. It cannot be mimicked or predicted. Consider it this way. Tension, the string's composition, and the surrounding area all affect the sound produced when you pluck a string on a musical instrument. Similarly, the tuning of interstellar space is revealed by these plasma waves. The frequency, strength, and patterns of the waves give scientists a previously unheard-of method of determining the material's density in this area of space. They discovered that the substance isn't as empty as we initially believed. It is packed with magnetic fields, charged particles, and cosmic dust, all of which interact intricately to influence how the plasma behaves. Now, the hum we're listening to isn't a coincidence. These plasma waves interact with the surrounding material as they traverse the great distances of space. These waves become more noticeable as the space gets denser. This implies that scientists might map out the different densities of the interstellar medium, the faint, hardly perceptible substance that fills the space between stars. By examining variations in the hum's frequency and intensity, we can depict the areas outside of the solar system using this type of cosmic cartography. That's not all, though. The characteristics of the space that Voyager 1 is traversing can also be inferred from these waves. Is it a wide, still space, or is it tumultuous and disorderly? What is its response to cosmic forces such as the solar wind? Every new piece of information Voyager returns to us adds to the enigma surrounding these fundamental concerns about the functioning of interstellar space. The behavior of these plasma waves may also disclose previously unknown facets of cosmic processes, such as the interactions between the waves and the interstellar magnetic field, or the effects of cosmic rays from far-off stars on our solar system's surroundings. Questions regarding how these plasma waves might evolve over time are also raised by the hum. Will the hum change as Voyager pushes deeper and farther into the void? Will the frequency change, or will it become softer or louder? What may that entail for space exploration in the future, assuming it does? One wave, one hum, and one discovery at a time, we are getting closer to discovering the deep, hidden secrets of the cosmos every day. Voyager's shocking discovery of cosmic rays. It was the shocking finding of cosmic rays, not simply the plasma waves, that caused people to take notice as Voyager 1 crossed the barrier into interstellar space. Although the existence of these high-energy particles, which move at almost the speed of light, had long been hypothesized amid the expanse of space, scientists were totally unprepared for their intensity. Scientists anticipated a gradual decrease in solar particles once Voyager left the solar wind's protective bubble. After all, our solar system is protected by the solar wind from a large portion of the powerful radiation and energetic particles that are released into space by far-off stars, black holes, and supernova remnants. However, when the spacecraft returned data, it showed something quite different. The cosmic rays were far more intense than expected, and there was no noticeable decrease in their intensity. Space itself looked to be teeming with an unseen, unrelenting force that seemed to pulse across the cosmos, just waiting to be found. These cosmic rays are more than simply a space background or an annoyance. They have tremendous power and can carry information about the universe's most extreme occurrences over great distances. Given their extreme energy, some of these particles could only have formed in the most violent known processes, such as gamma-ray bursts, supernovae, or even black holes consuming matter at galaxies' edges. However, scientists couldn't help but wonder, what else might these particles be teaching us about the universe? Voyager 1 discovered them. Are these cosmic rays a clue to dark matter and dark energy, or perhaps a path to deciphering the mysteries of distant regions? The fact that cosmic rays don't only move in straight lines across space is particularly perplexing. As they travel through the interstellar medium, the galaxy's magnetic fields have the ability to change their energy and modify their trajectory. Accordingly, scientists are learning more about the galactic magnetic fields and how they affect particle behavior in space by examining the cosmic rays that Voyager has discovered. As our understanding of these cosmic rays grows, we come to understand that they might provide the answers to questions we were unaware to pose. The ultra-high energy cosmic rays, particles with energies millions of times higher than anything we can create on Earth, are among the most puzzling. These particles appear to defy all of our understanding of physics, moving across billions of light years in space without encountering any obstacles or losing energy. Their origins are still unknown, and the mystery is only made more complex by the fact that they are located at the furthest reaches of our solar system. Is it possible that these rays are emanating from a distant galaxy? Might they be the remains of cosmic occurrences that took place ages before the solar system was formed? Furthermore, the detection of these rays by Voyager also prompts fresh inquiries regarding the possible risks they represent to long-term space travel. The strength of cosmic radiation could have major effects on our technology and astronaut health as we send probes and perhaps crewed trips into deep space. We still have a lot to learn about space and the forces that form it, as this discovery highlights. Voyager will continue to collect information on these cosmic rays as it travels deeper, offering ever greater understanding of their nature and origin. It seems like the universe is gradually disclosing its most fundamental and profound mysteries, one particle at a time, with every new discovery. And who knows what other incredible findings might be found in the unexplored regions of space as we keep pushing the limits of exploration. The Golden Record, a message to the stars. In addition to collecting priceless scientific data on the furthest regions of our solar system, Voyager 1 is discreetly delivering humanity's most important message as it continues its journey into space. The Golden Record, an archive of Earth's culture, history, and aspirations for the future, is concealed on a 12-inch phonograph that has been gold-plated. The record's contents represent a variety of life on Earth, including greetings in 55 different languages, music by Beethoven and Blind Willie Johnson, pictures of the people, animals, and landscapes of our globe, and noises that encapsulate our world. Similar to a fingerprint, it is left behind for everyone who may discover it, regardless of whether they are human or something else. It wasn't by chance that the Golden Record ended up aboard Voyager 1. It was created with the greatest care and purpose by a group of scientists and artists who hoped that someday a far-off civilization would find this time capsule
and discover something about who you live. The record conveys an indisputable message. Humans were here, even in the vastness of space, where it may take billions of years before any one creature finds it. It's a message of inquiry, hope, and the innate human yearning to relate to something greater than oneself. However, Voyager is subtly carrying a secret that is as profound as the record itself, as it moves farther away from Earth, beyond the planets, past the heliopause, and into the unexplored void, the mystery of what is out there. Voyager is advancing humanity into the future every day by collecting information on space conditions that may eventually help us find the answer to a question that has plagued us for thousands of years. Are we alone in the universe? The big unknown of contemporary science is, of course, this question. Voyager's data is assisting us in solving a far bigger cosmic riddle, even though it does not directly suggest extraterrestrial life. Voyager is providing us with important information on the type of environment that can support life elsewhere by investigating the interstellar medium, the nature of cosmic radiation, and the odd phenomena that exist in space outside of our solar system. For example, one of the most significant questions scientists pose is, what conditions must exist in space for life to flourish? We may eventually be able to determine the circumstances that could make other planets or moons habitable, thanks to Voyager's observations of cosmic radiation, plasma waves, and the behavior of particles in the interstellar medium. These discoveries may help us locate the best spots in the enormous cosmos to search for evidence of life, whether it be microorganisms or something far more complex. Despite years of research into Earth-like planets, those in the so-called habitable zone where liquid water can exist, Voyager's data is showing us that the term habitable may be more expansive than we previously believed. Understanding the various layers and behaviors of space, a dynamic and complicated environment, may help us discover new places where life may arise. Could life exist in places we've never thought possible? Like the underground waters beneath frozen moons, or deep within the clouds of gas giants? Hints from Voyager's ongoing mission suggest that life may originate from both particular circumstances and the fundamental behavior of space. Additionally, Voyager's discoveries are indirectly assisting us in refining the concept of life detection. We can learn a lot about the background conditions of space from cosmic rays, plasma waves, and radiation from far-off stars. We are becoming more knowledgeable about how to search for life in the universe, what indicators to look for, and what equipment could be required to find something as elusive as microbial life on a far-off exoplanet as we continue to investigate these phenomena. We might eventually have the means to find signs or indicators of life millions of light years away if Voyager's data can identify even the smallest changes in the cosmic environment. Therefore, Voyager's legacy extends beyond simply investigating the furthest reaches of our solar system. It's a voyage that continuously challenges our conception of space, stretching the limits of our knowledge of the cosmos and what might be out there just waiting to be found. It remains to be seen whether we discover extraterrestrial life. However, part of the deep legacy Voyager leaves behind is the quest itself, the desire for knowledge, and the unending curiosity it embodies. After all, getting to the solar system's edge isn't the only goal of Voyager. The goal is to spread the spirit of exploration throughout the cosmos and beyond, and we follow it as it ventures farther into the unknown, led by the questions. And as it ventures farther into the unknown, we follow suit, led by the inquiries that define our humanity. The battle against time. How long can Voyager last? There is an indisputable sense of wonder as we watch Voyager 1 and 2 venture farther into space. These spacecraft have been in orbit for decades, returning data that has fundamentally changed our view of the cosmos. However, this golden age of discovery will come to an end, just like everything else. Radioactive thermoelectric generators, or RTGs, which use the heat produced by the gradual decay of plutonium to produce electricity, power the probes. Although this has allowed them to continue operating for more than 40 years, these generators' power is gradually dwindling. The RTG's energy output is decreasing annually, and by 2030 or so, they could not have enough power to operate their scientific equipment. At that point, Voyager will become silent and the data will stop. Nevertheless,
Voyager will keep sailing even if its electrical heart slows. It will continue to float through the vastness of interstellar space for millions, if not billions, of years if no outside factors intervene to alter its course. It's a frightening thought. Even if its power fails, the probes themselves will carry on with their voyage, silently, across the icy darkness, bearing the golden records, humanity's legacy. Long after the probes are no longer able to return data, these records, encoded with the essence of life on Earth, will remain intact. Even if no one is around to listen, their voyage will serve as a permanent reminder of human curiosity and our drive to explore the universe. However, Voyager continues to offer priceless insights for the time being. It keeps sending valuable data every day that no other spacecraft can. In areas of space where we would otherwise be totally blind, Voyager serves as our eyes and ears to the cosmic rays, plasma waves, and magnetic fields. Its results are not only useful, but also unique, because no other spacecraft is able to measure the interstellar medium. In an effort to comprehend the immensity of space and our role within it, scientists from all around the world are assembling the puzzle piece by piece with each new communication. The fundamental nature of the universe outside of our solar system is being revealed by these seemingly insignificant measurements. In order to better understand how the solar wind and the interstellar medium interact, for example, Voyager's instruments are demonstrating to us how the effect of our sun diminishes as it moves into the larger cosmic environment. In addition to answering questions about how charged particles move through space and shedding light on the galaxy's magnetic field lines, Voyager is also giving us a better understanding of the environment that exists in the gap between stars. We get closer to comprehending how the universe functions on the biggest scales, and how we might eventually traverse it with each new piece of information. The remarkable thing is that Voyager is assisting us in creating the frameworks and instruments required for upcoming interstellar travel. The information gathered by Voyager will be essential when humanity finally constructs ships that can go far outside of our solar system. It serves as the cornerstone for upcoming missions. Understanding the behavior of the interstellar medium can help us identify and investigate new worlds and better prepare for the difficulties of long-duration space travel. Voyager's journey has a sense of poetic inevitability, even though it is impossible to pinpoint the precise moment at when it will go silent. Its continuous existence is all the more significant given that it will float across space, far beyond of our reach, and without any active connection from Earth. Floating far out in the vastness, its message and data fading into the background noise of the universe, but permanently there, a tribute to the curiosity and amazement that inspired its creators. It will become a cosmic relic, a silent sentinel of humanity's most audacious goals. But for the time being, this amazing spacecraft continues to provide us with data. As if the cosmos itself were gradually whispering back to us through Voyager's instruments, the streams of information persisted, but were progressively fainter. Before the probes ultimately stopped talking, we have no idea how much more we will discover. However, as they continue to return their last communications, there is no question that Voyager's legacy will endure. A legacy that echoes the spirit of human discovery, for as long as the universe permits, transcending time and space. Voyager versus the black hole and encounter. Although that may seem like science fiction, the possibility of Voyager coming into contact with a black hole is far less dramatic in reality. Although black holes are fascinating and have a magnetic appeal for both scientists and space fans, the reality is that they are extremely uncommon in the vastness of space. Although there are many black holes in the universe, most of which are found at the centers of galaxies, there is very little possibility that Voyager 1 will come into contact with one. Why is that? To begin with, Voyager is presently traversing the outermost regions of the Milky Way, which are devoid of black holes. Instead of being dispersed over the outer regions, the dense groupings of stars and the black holes that accompany them are usually found far closer to galactic centers. The spacecraft is currently traveling into interstellar space, but the distances between these celestial objects are so great that there is very little chance of a chance encounter. Additionally, Voyager's path is meticulously charted. It's not simply floating aimlessly. Its speed is precisely monitored, and its path is known. It is traveling toward the constellation Perseus, which is a peaceful area of our galaxy where it will spend millions of years traveling without encountering any gravitational forces that could be dangerous. The reality is far more peaceful, even though the possibility of Voyager being captured by a black hole may make for an exciting story twist in a science fiction book. Voyager is merely evolving into a silent traveler on an unending voyage, bearing the legacy of humanity and providing insights into the profound mysteries of space, rather than racing into peril. Voyager's comparison to JWST and Hubble. Voyager is on a totally different but no less significant mission than the Hubble Space Telescope and the James Webb Space Telescope, JWST, which both take breathtaking pictures of far-off galaxies, exoplanets, and the deep regions of space. Voyager is concentrated on a more local frontier, the outer boundaries of our solar system, and the area immediately beyond them, while JWST and Hubble look outward, exploring the most remote regions of the observable cosmos. It is the spacecraft that is investigating the neighborhood that is closest to us, measuring the interstellar medium, and collecting information on the behavior of space where the impact of the sun starts to diminish. Finding habitable exoplanets millions of light years away or solving the secrets of distant galaxies are not the goals of Voyager. The goal of its mission is to map the solar system's borders instead. Voyager is advancing our knowledge of the transition from the solar wind, particles expelled from the sun, to the silent, dark regions of the galaxy as it moves more into interstellar space. Scientists are using this data to better understand how our solar system interacts with the larger cosmic environment, which makes it essential. The fact that Voyager is giving us information that telescopes and observatories cannot provide is what makes its discoveries so important. In ways that telescopes just cannot. Its equipment are measuring the behavior of magnetic fields, cosmic rays, and plasma. It provides information about the interactions between galactic forces and the solar wind, as well as the behavior of the universe on a small scale, just outside the sun's sphere of influence. Voyager serves as humanity's ambassador in deep space in a number of ways. It is our first actual envoy to the stars, bringing back to Earth information that will influence future generations' perceptions of the cosmos. Voyager's data will continue to deepen our understanding of the space we live in and its relationships to the larger galaxy, while JWST and Hubble continue to probe the far-off cosmos. Every bit of data that Voyager returns to us helps us understand the local and interstellar environments, adding another component to the universe's jigsaw. The basic nature of Voyager's discoveries makes this particularly interesting. It helps us ask the correct questions, not just provide answers to particular ones. Future space missions that may eventually depart from the solar system, or perhaps visit far-off stars, will rely on Voyager's data to better comprehend the physics of the interstellar medium and provide insight into the behavior of cosmic particles. Voyager's peaceful, unrelenting study of space reminds us that our voyage into the unknown is only getting started, even as new telescopes peek into the depths of space. The end of the journey? Voyager's journey becomes more than just a scientific endeavor as it gets farther away from Earth. It becomes a representation of humanity's insatiable curiosity. It pushes the limits of our knowledge and challenges us with every new piece of information it returns. Not only is it providing fresh information about space, but it is also changing our perception of the cosmos. We are forced to face the grandeur of the universe and the mysteries that remain buried in its depths, more and more as Voyager continues its journey. The probe continues to provide discoveries that challenge our assumptions, even as its power wanes. By illuminating the physics of interstellar space, cosmic radiation, and the intricate relationships between the solar wind and the galactic environment, the discoveries it is making at the very end of the solar system are challenging our preconceived notions of what was conceivable. On the journey to comprehending the actual nature of the universe, every signal that Voyager returns is like a breadcrumb. Beyond its scientific significance, however, Voyager's mission has a profoundly personal backstory. It stands for our shared desire to investigate, find solutions to the mysteries, and make a significant contribution to the cosmos. Voyager's golden record is a quiet invitation to any future explorers who might come upon it, a time capsule of humanity's existence and a snapshot of who we are. It conveys a message of curiosity and optimism. Voyager will continue its solitary voyage through space for millions, if not billions of years, even if its active mission will eventually come to an end. A reminder that we once looked to the stars in an attempt to communicate with something bigger than ourselves. A message that another civilization may one day find. What other secrets will it uncover? Could these discoveries change everything we know about the universe? Let us know your thoughts in the comments. And don't forget to like, share, and subscribe for more mind-blowing space discoveries.